in Count the Blocks Educational Codeforces Round 84, in which we are given some number n. We need to first enlist all the numbers by left padding. Uh, all the numbers of size, of length n, that is the length in decimal representation should be of length n. If it is not, then we need to left pad with zeros and list out all the integers from 0 to 10 power n minus 1, and then count uh, count the number. So for every I, count the number of blocks of length I among all these written integers. And what do we mean by a block of length I? A block of length I is the maximum contiguous subarray of the same element that can be formed. So, for example, in this, if for example, if n in n, if the given n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If the given n is 11, then this is a block of size 3, this is a block of size 1, this is a block of size 2, this is a block of size 1, this is a block of size 1, and this is a block of size 3. Yeah, so the way we can solve this is, first of all, let's see what happens for n is equal to 1. So if n is equal to 1, we have only this place to fill. We can have 10 options, that is 0, 1 up to 9. So the answer is 10 options. If n is equal to 2, we have 2 blocks to fill. Now, okay, so if we are considering blocks of size 2, that means that both of these blocks should contain the same digit. And how many choices do we have for such digits? That is 10, 0 to 9. Plus, if each block has independent digits, that is different digits, then for this block we have 10 options, then for this block we have 9 options. And similarly, so this is if we the number of uh, blocks of size 1, uh, yeah, number of size blocks of size 1 in this place. And similarly, we need to find for this place. Similarly, for this place, the answer would be 10 into 9, that is 10 options for this and 9 options for this. So the answer for this case would be uh, this for number of blocks of size 1, and this is number of blocks of size 2. So the answer, the way we report it is 180 comma 10. This is what is given in the input as well. Okay, so now generalizing this idea uh, for the, let's consider this, let's consider n places, and let's consider that we need to form a block of size k, of length k, right? This is k. Now the way the answer for this is, if we need this to be size k, this all these elements would have the same all these indices will have the same element, and there are 10 such options. These two indices must have uh, can have any digit, but not the digit that is chosen here. So it has 9 options here and 9 options here, and all the remaining digits can be anything, so 10 options each for them. So if this is the for the case when the window of size k does not share a corner, that does not lie towards the does not start from the left or does not end on the extreme right. This is for that case, and the number of such blocks would be uh, 10 for this, into 9 square for this, and Okay, so this is k plus 2 elements have been considered from this to this, and the number of elements remaining are, uh, let's say, number of remaining elements are depicted by pow, and they are given by n minus k minus 2. Yeah, so this is the number of blocks of size k with not which are not sharing, which do not start from the extreme left or end towards the extreme right. Now, considering the case when it does start from the extreme left or extreme right, in that case the answer would be 10 options for this, 9 options for this, and 10 options for each of them. So that is 10 into 9 into 10 into pow, uh, pow plus 1. That is, these are basically n minus k minus 1 elements, because these are k elements, these are 1 element, this is 1 element, and the sum should be n. So this is the answer. So the cumulative answer, so number of blocks of size k would be 10 into 9 into 10 power power. So that is this term plus this term. That is 10 into 9 into 10 power power, 90, or rather 9 plus, okay, and right, and this is the number of blocks of size k, and we'll have, uh, so this is for one, like this for one window. Now we need to consider n minus k such n minus k. So if we n was 5 and k was 3, we would have had to consider 3 such windows. Yeah, so n is equal to 5, k is equal to 3, we need to consider 3 such windows. So we need to consider n minus k plus 1 such windows. Uh, right. So the answer would be, uh, 10 into 9 into 10 power power, 9 into n minus k plus 1 plus, 9 into plus, and for this these are, there are two such windows, that is one starting here and one ending here, so plus 2 into 10. So this is for k less than equal to n minus 2. For k is equal to n minus 1, again we have like two options, either this or this, and the answer would be 10 into 9 plus 10 into 9, that is 180. For k is equal to n, we have just one option, so just 10 options. So 10, 180, and then the answer would be reported as these. Now, moving on to the code. Code is very simple, as we discussed. If n is equal to 1, this, n is equal to this, otherwise just calculate the formula from the formula. That is it. Yeah, yeah, that is it. Do we have the correct formula though? Should this be n minus k plus 1 or n minus k minus 1? K, because the total number of, uh, this should be n minus k minus 1, because n minus k plus 1 is the total number of sliding windows, total number of windows of size k that slide on a array of n, while two windows are considered in this, like in this part. So for this we have n minus k minus 1 windows left, and Similarly, for the answer also, you can see that n minus k minus 1, uh, this is n minus k minus 1, which is this term. Yeah, that's it.